You know, what if I told you that there was an ancient mathematical system that wasn't just for scholars and dusty old scrolls, but was actually designed to run an entire economy? I'm talking about a powerful engine for daily life, for commerce, for making decisions, and it's been almost completely forgotten. In fact, it was described as exactly that, a system, not just for scholars, but for life itself. This was the incredible vision of the Indian mathematician Sridharacharya. He developed this whole framework centuries before our modern world even started to formalize these exact same ideas. Okay, so let's really dive into this. What exactly was this forgotten math engine, and what made it so incredibly powerful? Well, at its very core, Patiganita was a complete economic and motion model. Now think about that. This wasn't just about abstract numbers on a page. No, this was a practical, hands-on framework for understanding the real world, everything from how money moves through a market to how travelers move across a landscape. And that practicality, well, that brings us right to its real purpose. See, this was never theory for theory's sake. Patiganita was truly, and I mean truly, a system designed for life. And when you look at the sheer range of what this thing could do, it's kind of mind-blowing. On the one hand, you've got all the building blocks of commerce, right? Simple interest, partnerships, rules for buying and selling. But then it also covers physics, like figuring out where two travelers will meet, and even complex engineering problems, like those famous cistern puzzles. The point is, these weren't just a random collection of math problems. They were all interconnected parts of one single powerful model. And this is where you can see just how far ahead of its time this thinking really was. What they called alligation of gold, which is basically figuring out the purity when you mix different metals, that's the same fundamental logic we use today for balancing a financial portfolio. Their cistern problems, that's pretty much an early model for flow dynamics. And the rules for partnership, you guessed it, they're essentially profit-sharing algorithms. The names have changed, but the core logic is unbelievably modern. So, here's the most crucial takeaway from all this. Sridharacharya wasn't just teaching people how to add and subtract. No way. He was teaching them entire decision-making systems. He was literally giving them the mental tools to tackle complex, messy, real-world problems in a systematic way. So we've seen what it could do. But the next big question is, how? How did this whole system work? Well, beyond all the day-to-day stuff, the entire framework was built on a deeply powerful idea called the power of series. This foundation was called Sreni, and that's pronounced Shreni. Now, Shreni is the study of mathematical series. And we're not just talking simple stuff here. This was a deep dive into arithmetic and geometric series, and even really complex series involving the sums of squares and cubes. It's basically the mathematics of patterns and growth itself. And why should any of us care about that today? Well, here's the kicker. These ancient concepts, they are the mathematical engines of growth that we still use. An arithmetic series, that models linear growth, a steady, predictable increase. But a geometric series, that models exponential growth. That's the explosive logic behind everything from the compound interest in your savings account to how a video goes viral on the internet. It is a perfect example of how the language may be ancient, but the logic, it is absolutely timeless. The very same principles that Sridharacharya was laying out are now hardwired into the financial forecasting models and the data science algorithms that literally shape our modern world. But here's where the story gets really interesting. Among all these incredible ideas, the source material points to one specific rule that just stands apart from the rest. A single contribution that wasn't just an improvement, it was a truly revolutionary innovation. So what was it? What was this one groundbreaking rule that seems to have just appeared out of nowhere? It was called the chain of measures rule. And at its heart, it's this incredibly elegant and systematic way to convert across multiple different units in one single structured operation. So imagine going from meters to centimeters to millimeters, all in one clean, logical flow. Today, we'd recognize this in a heartbeat. We'd call it something like a conversion pipeline or a data transformation chain. Now, here's what's so remarkable. This specific rule, it hasn't been found in any of the major mathematical works that came before his. All the evidence suggests this was a genuine first, an original idea that he introduced. This shows us he wasn't just a curator of old knowledge, he was a true innovator. And that single innovation created a ripple effect through the entire world of mathematics. And that brings us to its truly timeless legacy. Okay, so just follow the timeline here. Before the 10th century, Sridharacharya introduces his rule. Then, by 1073, another mathematician is on record giving him explicit credit for it. And soon after that, his innovation starts popping up in the works of other major mathematicians. You can literally watch how a single, powerful idea, once it's out there, gets adopted and spreads, changing scientific thought for generations to come.
Pātīgaṇita.
That's what they called this incredible framework for understanding the world. But what do we call these exact same ideas today? We call them algorithms, models, systems. The tools we use every single day to navigate our complex world, to predict markets, to build technology, to make critical decisions, they're not nearly as new as we think they are. They are simply the modern expression of a very old and very powerful idea. Ancient knowledge fueling our modern intelligence. If this helped you understand, don't forget to like and subscribe for more powerful concepts.